Hello everyone, and this is not really a tutorial, I'm just demonstrating how to use attributes and OSL in Octane. Now, I'd been wanting to make this a while back, but the issue was that even though Octane can use OSL, which is short for Open Shading Language, Houdini wasn't supporting it. There was like the developer was still implementing it. So with this version of Octane, like this current build, which is 2018.1 release candidate 6, which is the absolute latest one. With that one, the developer finally implemented OSL into Octane for Houdini. So I figured, okay, I'll just make a short video that covers that. Now the thing is, Octane does support attributes now, but it is only for meshes. So it doesn't support attributes for particles or hair. That's coming in the next version. So it's sort of like half an implementation. But okay, at least you have something, Okay, so the first thing is I'm not a programmer, but like OSL, if you know Vex, OSL is relatively close. So a lot of the basic stuff that you could do with you can do with Vex, you can actually do with OSL as well. Now, the one thing that is sort of an issue is the OSL texture that you get, you can't edit the code. You have to it will load the code and then it will build the user interface for you. So the way you have to do it is, if you have an Octane license, you also have Octane standalone. So you build the code in here and you test it out in Octane standalone, and then you can just save it as an OSL file and then load it up into Houdini. So once you have a decent library, you don't need to do that anymore. So just to give like a basic example of the various shortcomings of Octane and how you can use OSL to solve some of those things. If you are, as I said, like if you are a coder, or if you've done a little bit of shader programming, you can push it a lot further. With OSL as well, there are a few limitations within Octane. I think like implementing a shader language on the GPU is fairly problematic. From whatever I've read overall, like GPU programming is a lot more complex than programming for the CPU. I'm not a programmer, but that's what I've read. Anyways, so the current limitations with OSL implementation in Octane are, firstly, you can only get one output. Okay, like with some of the examples I've seen, OSL can actually give you multiple outputs. But currently with Octane, you can only get one output and it can only be color. Okay, it can't be a float output. The other issue is that it doesn't support OSL shaders. It only supports OSL textures. So you can't code your own shader. But the point is, Octane has a fairly decent variety of shaders now, in the sense of like you have a full universal material which has like multiple coatings and all of those things. And I believe with the next version they're implementing like a full layer based shading system. So I guess coding shaders won't be as important, but anyways you can't do it. Okay, you can't code shaders. So what happens with OSL is, if you type OSL, you get 4 shaders. Okay, you get a basic projection OSL, you have a texture OSL. So the projection OSL is actually quite useful if you want to distort UVs. The projection OSL is quite nice. I'll do another example of that. I don't have anything, like I have, but it's an Octane standalone. The texture OSL is where you can actually build your own textures. And then you also have like a camera OSL. Okay, which is like if you want to build a custom camera, like maybe you want to build like a fisheye lens. And if you know that level of coding, you can actually build a custom camera. Anyways, so I'll give you like a basic example. So one of the issues I faced a few months back was that I had downloaded a series of or a collection of terrain textures, full, like it had height maps and displacement maps and flow maps and all of that stuff. Really good stuff. I don't know the link. I'll look for it and put it in the video description, but I don't know the link at the moment. The problem that happened with that was that this is one of them, is the flow map is actually this RGB texture, okay, which is kind of a first for me. I understood what the what the person had done was essentially, this is not just the flow map. This is probably like the flow, the debris, and maybe water. Like you have all three of those together. And what he's done is they're grayscale maps. So in order to save space, he has put each one into into one channel. So the red channel is like the flow map, and the green channel might be debris, and the blue channel might be something else. So he's taken like three different maps and just put them into one. But the problem happened is like with Mantra or Arnold or Redshift or whatever, you do get like a vector to float, right? Octane doesn't have a vector to float. So the issue became like, okay, what do I do now? Now there is a really complicated method to get your channels out, but it's too cumbersome. Anyway, so that's where sort of something like OSL comes into play. So the code itself becomes very, very simple. So just to sort of show you, so this is my, I've sort of like reconstructed it, but this is the basic image that I have. And I wrote a very simple code to extract channels out of an image. Okay, but when you're extracting channels out of an image, it's essentially you're doing vector to float, right? Like if you have an RGB image and if you take out R, G and B, that's technically you're taking out, float channels out of a vector. And the code itself is really, really simple. So if I look at the code, okay, this is the code. Like actually it's just this much. Okay, this is just declaring like the initial interface. Okay, so what this is you are defining an input. Okay, so I have something called color M. Okay, so which is like this is color M, like you can read the M over there. And then I need a channel. So I have an integer called channel. And then you need to define an output. Okay, so the output will be a color called anything. And then the code is essentially I'm taking C is the input color and whatever channel. Okay, so I can just go 0, 1 and 2. So it's sort of like if you look from a VEC standpoint, it's like 0 will give you red and 1 will give you green, and 2 will give you blue. But we want an actual interface. I don't want to go in and type. So which is why I'm using the channel parameter that I have created. So once I've done that, we won't save it. But then if I go 0, 1 and 2, you'll see it goes through all three channels. And then I reversed that and I created like a float to vector, which is if I open up this one, you'll see all it does is it has 3 inputs and I'm just taking like the first one of each, because you can't, like, a grayscale is still an RGB image in Octane. So I'm inputting all 3 and I'm just saying the color is like the first channel from the first image, the first channel from the second image, and the first channel from the third image. Right, so I'm just taking like R0, G0 and B0. And if I plug it all in, like this is, you basically get the same image again, because this is what it is, right? So this is the red channel, and then this is the green channel. Okay, hold on, like that's the green channel, and then that is the blue channel. Okay, so I plug in all 3 and I get my image back. And so like these are literally like one-line codes that you can have, but they solve a fair bit of issues. So if I look at this particular image, you'll see the issue almost immediately being solved. Okay, so what I've done is so the way it works is once I've saved the OSL file, which is just a .osl file, you just take your texture.osl and you can load it up. So I have a folder called OSL textures, and I'll just pick up, I have something called vector to float. Okay, and then just hit compile and build and it'll put in the function. So if you plug this, you'll see that what you're getting is this, which is like fully colorful. Okay, and then if I just plug it through the OSL texture, see, so this is, now the problem that happens is like the range needs to be set. So even if you just manually type it, it's fine. But what you can do is you can go to the parameter interface, click on channel, and then take it from like 0 to 2, because that's the range that we want. So this is red, and then this is green, and this is blue. Okay, and so now what you couldn't, or what would be a fairly longer process earlier, if you have like a simple, this code snippet, you can fairly easily, solve those issues. Okay, so this is one example. The other is, even though it doesn't support for particles, I'll just sort of, demonstrate something else, because Octane does support attributes now. So what you can do is, I have this really simple particle system that I created. And what it is doing, to just show you the particle system, is that it starts off fast and then it kind of slows down towards the end of life. So what I have is, if I look at it from a color standpoint, I actually created like a couple of groups. Okay, so I'll just give this, let's make these like dark blue. And then I created a group, which is, I'm just taking the age, like whatever is over 50% in age. Okay, so half the life is going into this other group called slow. And then all I'm doing is I'm just taking the velocity and multiplying it by 0.5. Okay, so for that particular group. So you'll see, like once they come to a point, they all start to like really slow down. And so just to show you that group, if I take another color, and this is for slow. Yeah, and let's make it, and what can we make it? Yeah, okay, like it's the opposite way, but fine, so you can see the ones that are slowing down. Okay, like let's get rid of these. I don't need the color channels. And what I've done temporarily is I've just copied like a bunch of boxes on it. Okay, so I have like these boxes over here. And I'm deleting most of the attributes. I'm transferring a few. I'm transferring the age and the position and the velocity. So now the way it works is very similar to Redshift, which is you will get, when you add the object properties, you will get a tab called attributes, and you have point float attributes or point vector attributes. Primitive attributes, usually you want to transfer them over to vertices and then plug it in over there. So for the vector attributes, I'm using velocity and position. For the float, I'm taking age. I'm just going to work with velocity for now. So again, if I just come in here, I've assigned a material to it, and let's just come in here. Okay, so let me just hit IPR again. We'll hit full reload. Yeah. Okay. So if you type attribute, then you'll get something called color vertex and float vertex. Okay, like it's still, they're going to work for everything. Okay, I think you should just call them color attribute and float attribute. Remove the vertex altogether. But the color attribute is a vector and the float attribute is a float. So we'll just take color and we'll type V, which is for velocity, and I'll just plug it into diffuse. And there you go. You are bringing in the velocity. So now, again, like if you want to like a vector to float, let's say I just want to extract, like X, Y, or Z, I can just plug this in over here and I bring it out. And there you go. So now I have like, this is the X and this is the Y and that's the Z. Okay. So that's one thing you can do. But another thing that you can do is, I wanted to calculate the speed. So the speed is essentially, the code is fairly simple. The speed is the length of velocity. Okay. So length of V is technically velocity. So what I did was I just came back here and I actually built up a code for it, which again is very, very simple. So if I just load it up and look at length, see, that's the code. So you have your input color. Okay. And then it just says color is length of the input color. That's it. And so if I loaded that, or let's just load it again, so I'll just take texture, OSL, and we'll load up length. Okay, maybe I should change that to speed, like that will be better, and just do compile, and that's essentially it. You just need the color input. So I just plug this in and I plug that out and hit IPR, and there you go. So what you're calculating now is you're calculating the speed. So you'll notice like as they get faster, they get white, and then as the ones that start to slow down again go back towards black. So if you want to like calculate the speed of your particles, you can actually do that. And then if I plug that through a gradient, so now you can have a texture that is based on the speed of your particles. I'll do a proper video on how to write basic OSL. It's not particularly complicated. The one thing to understand is, even though OSL is like open shading language, adapting it from one software to another or one renderer to another is tricky, right? Like because Arnold supports OSL, and you have an OSL implementation in Max, and a whole bunch of them support OSL. But in order for them to work between renderers, some code has to be changed. So I can't just take a map that works for Arnold and just do a copy paste and have it work in Octane. It doesn't work that easily. You do need to make some changes. Also, the issue, as I said, is that Octane doesn't support all of OSL. It supports like 70% of OSL. Like if you leave out the shader stuff, it supports majority of the texture stuff, but even there it has, I believe there are some things that it doesn't support. Like it doesn't support float variables, right? Like it can't output a float. It can take an input of a float value, but it can't output a float. So that's still an issue. But yeah, so the way I work is when I want a float variable, like when I want to output a float, I just output a grayscale image. Like it works that way. Anyways, I was doing a little bit of OSL, but since it wasn't working in Houdini, I kind of stopped trying it out. But I'll do a few more, and maybe when I have a little bit of time, I'll upload like a library of OSL textures that I've written. Like not too many, I'm not a coder, but maybe at least like 5 or 6 or 10 basic things that you can use on a day-to-day basis. Because I did manage to write a few things, like I managed to write like a basic layer texture. Okay, like just 2 layers, but you have like Octane has like divide and add and multiply, but they're all separate. So I wanted to have all of it in one with just a simple drop-down list with like masking inbuilt. Alright, so since I mentioned the Photoshop layer stuff, I figured I might as well just show that as well. Now right now I can only get like 2 layers, so a base layer and a second layer, and some basic blending modes. Okay, so it's fairly straightforward. Like I'll make this one available as well. So I have this thing called Photoshop layers, and if you compile it, what you get is you have I should rename these, but yeah, I have like layer 1 and layer 2, and then this is the mix value. Okay, and then I have about 6 or 7 different blend modes. These are the basic ones. Like I couldn't figure out how to do overlay. The math for overlay is a little complex. So whenever math goes too complex, I can't figure out what to do with it. Anyway, so let me just hit IPR. And what I have these 2 maps, like this is one and this is another one. Okay, and then I can just mix these together. So I'll just plug these in. And yeah, there you go. So you can just increase the mix amount and you can mix between these. So the point is Octane does have like a mix map and some basic mixing modes, but they're all separate. So the idea with this one was to just have everything in one. And then you can have it on multiply, add. You can do subtract a minus b or b minus a. So you can get both. And then there's divide and color burn. I haven't figured out how to do more than 1 layer as yet. Again, like I just started off with the basic and then I didn't really, carry it forward. I'll see as and how I get time, because I'm also building my new training. So as and how I get time, I'll try and, improve on this. If somebody knows the math for overlay and soft light, because those are the only 2 major ones that are missing from this, I'm going to make this available. So if you want to modify this, you should be able to. Like again, this is not a very complex code, and you can actually open up an OSL file in Notepad. Yeah, so this is the basic code for this particular OSL file. Again, so what's happening is, So this is all the interface stuff. So I have my layer A and layer B. Okay, those are the labels for it, but it's actually just M and B, which is why you're seeing M and B over there. And then you have the mix value. And then these are all the labels for the interface, so linear burn and all of that. And then what I have essentially is for all of them, I'm just specifying, the math for it. So multiply is M into B, and then add is M plus B. And then these are the ones which I found online, the ones that I could figure out. So you have the color burn math and the linear burn math. And then depending on whatever is the index value, it will switch between that. Okay, so it's fairly sort of straightforward. This isn't very complex. Anyway, so I'm going to make this available. So if somebody knows how to do overlay, you can make an addition to it and you can upload it, or you can send the OSL file back to me and I'll update it on my Dropbox, like whatever is preferable. Anyway, so this is another example of what you can do. What I need to figure out, or what I want to figure out, is how to sort of turn this into a digital asset. So we can just press tab and get it here. Okay, like that would be a lot simpler. So yeah, so that's essentially it. So this is using attributes and using OSL in Octane, and how it sort of helps you solve certain issues that Octane has. If you don't use Octane, who cares, right? You can just happily not worry about any of these things. Okay, here's a question for whoever watches this. If anyone knows what is the code for like a fit range, or how you can write a fit range in OSL, if you can put it in the comment section, I'll try and adapt it. Like that's the one map that I couldn't figure out how to write. Okay, like I found a code somewhere, but I couldn't make it work. But so if you can, that will be really useful. Anyways, that's basically it.